Hey Peacock, just wanted to give you an example here. So you have your energy level sketch on page 1, but then on page 2, there's an example. So we're sketching the graph of this function f here. So for the roots, I can see that there is a double root at -2. So I'm going to go ahead and put a double root at -2, like that. And then a single root at +3. Remember, you're switching the signs, and a single root at +5. Right, so those are my roots there. Kind of ugly, but we'll get past it. It's really good. All right, nice. All right, so the end behavior, the equation overall is positive. The reason I know that is because there's not a negative out here. I didn't have to factor out a negative. There's no negative, so it increases at the end. If it was negative at the beginning, it would decrease at the end. And I'm not talking about this plus sign here. I'm talking about like having a negative outside of the parentheses there. So it's positive. So I know at the end, it's going to be going up. So it's going to be going up like this. Cool. So then I know this was a single root, so I'm going to go through. I know this is a single root, so I'm going to go through. And I know this is a double root, right? So I'm going to touch it and then bounce back up like that. Right, so I can see that W shape for x to the 4th. I know this is x to the 4th because this was x squared. There's an x here and an x here. So if I multiplied all those together, I'd get x to the 4th power. So I know this is x to the 4th. I know that it's positive. That's why it's headed up like a cup. And then finally, the y-intercept, I know is 60 because I would have I have +2 here, and there are 2 of them, remember? So +2 times +2 would be 4, times -3 would be -12, times -5 would be +60. So 12 times 5 is 60. So I know this point right here is my y-intercept, and I'm going to label it as 60. Right. Obviously, the real graph looks something, a little different. Let me see if I can. We'll pull up Desmos here, like a calculator, and drop it in here. So I can see that this graph, I'll go ahead and adjust my axis here. We'll try like -200 and oops. -200 and +200, just so we can see the graph. So we can see sort of that same idea here, right? It's going down through 5, coming up through 3. It's hitting the y-axis at 60 and double rooting at -3. So you can see we had to adjust our axes a little bit in order to be able to see it, but you can see all of those critical points. And the critical points are what I'm looking for in your sketches. So you can use that as an example. You got this, guys. Okay, I also wanted to show you slide 8 or number 5. And the reason why is because this is a 3 minus x. We want to put the x in front for that term. So for that one, it'd be like -x plus 3. So you can imagine like what would make this 0? A 3 right here, a +3 would make this 0. So even though this is a plus, a +3 would add into this negative that's already there. An easier way to think about this is if you factor out the negative to take it to the outside, you would have x. You would need to take away the negative from here. So you'd have -3, right? And now you would see, okay, this is a single root at +3, and it's headed down, right? This is headed down because of this negative. So let's see our other ones. We also have a double root at -1 because those are the same there. So at -1, I'm going to have a double root here. So I have my single root of -3. It is negative, right? That would make this entire thing negative. So it's going to be headed down like that. It's a single root here. And then it's a double root here. And then that means that it's bouncing like that. So we can still see that cubic action, right? We have x times x times x. That would be x to the 3rd power cubic, but it would be negative overall because we factored out that negative, right? Um, we also can find the, once it's in this format, we can find the y-intercept. So we would have 1 times 1 would just be 1. And then since we factored this out, we have a -3 here. That would make -3. But we have the negative in front, so we'd have +3. So this point here would be +3. All right. Um, if you want to see this in like its full glory, we would have the negative in front. We have x plus 1. We'd have x plus 1. And we would have x minus 3. So if you're still thinking about this point here, right, we would say, okay, we have a negative times 1, which would be -1, times +1, still -1, times -3. That would give me +3, this point here. So that's how we do number 5. All right, I also want to show you slide 10 or number 7. This one we do need to factor. They tell us what the equation is, and we need to factor it first. So I recognize that this is x to the 4th, x squared, and a constant term. So this is like the x factor, but with that like grown-up version. So if I'm going to factor this out, I need to know what multiplies to get +4, but adds to get -5. So I'm thinking -4 and -1. So I'd say, okay, I have x squared minus 4 and x squared minus 1. This x squared times x squared would give me x to the 4th. X squared times -1 is -1 x squared. -4 times x squared would be -4. So -1 and -4, that would make the -5. And then -4 times -1 would give me the +4. So I know that this is correct. However, I know that I can take it a step further by saying, oh, that's the difference of squares. So I can break this into, x plus 2, x minus 2. This is also the difference of squares. So I can break this into x plus 1, x minus 1. So this is factored, but this is fully factored, like completely done. So I want to delete this part. So I can see that there are 4 separate zeros here. I have -2, +2, -1, +1. Right? Remember the factors are the opposite. So I'm going to go ahead and go here, say -2, +2, -1, +1. I see overall it is positive. The leading term is positive. So I know that it's going to be headed up. Like, whoa, not like that. Headed up like this. And they're all single terms, right? So I'm going to go ahead and go down this way, up this way, down here, and back up like this. All right. And then if I'm looking for my my y-intercept here, I know it's going to be +4 because it's my constant term. If I didn't know that, I could also do +2 times -2 would be -4 times +1, -4 times -1, +4. So I know this point here is +4. And based off my graph, I can see that it's positive. All right, guys, that's how you do number 7. Let me know if you have any questions. You guys are going to be great.